Okay, so I hope my voice is clear. Let's start with our today's topic. Our topic for today is algebra. Now, it's a very important topic when it comes to, for example, if I'm talking about the O-level students or the IGCSE students, it's a very, very important topic and it holds a lot of weightage in your final exams. So, a student can expect roughly up to 25 to 30 marks within the algebra portion of your exams, right? Okay. Now, this algebra portion is divided into many different subtopics. The first one that we're going to be studying today is indices. It's the topic that is going to help us examine what sort of important concepts we need to know in order to make sure that our concepts remain unchanged. Then the second thing that we're going to be studying is factorization. How do we factorize most types of equations? The third most important thing is quadratic and equation solving. Quadratic and equation solving. Then we have making subject of a formula. Then we have a very important concept which is solving simultaneous equations. And then we have algebraic expressions. Right? So, as of yet, these are the most important topics that we are supposed to know. So, let's start with indices first. I want you to write all of this down and then we can move forward. Yes. Done writing? Okay, okay, no worries. Okay, so first and foremost, our topic for today is indices. Now, what we need to know is that why do we come up with this idea of indices? What's the reason? Let's have a look at two terminologies and then let's determine from where do they come and what is their importance. If I have a base, for example, if I have a letter and I can call it a base, and if I have a power over it, what does this power signify? Now there are few terminologies that you have to know. This will be called a base, and this is called the index, or it is also called a power. The plural form of index is indices. So this is the plural form, right? Now, what we actually need to know is that imagine, for example, if I ask you to measure the distance between, let's say, from London to New York, the distance that is going to be measured will be in kilometers, right? And if I ask you to measure the distance between one palm of your, the palm of your right hand to the palm of your left hand, that distance is going to be in meters ideally or centimeters, right? Now, when we are converting centimeters to meters, we are going from a numerically smaller value. If I am going from centimeters to meters, or if I am going from meters to kilometers, where am I going? I'm going from a numerically larger value to a numerically smaller value, which means 0.0005 centimeters will be written as 0.05 meters in the form of meters, right? So if I have to write 0.005 in a standard form, I will be writing this as 5 multiplied by 10 raised to the power of 1, 2, 3. 3 um, numericals behind 5 into 10 raised to the power of minus 3 centimeters, right? And then just like that, this method is going to continue. So what we actually need to see is that from where do we have this idea of indices? Now this idea is known as indices, and that's why we have to study the importance of indices. Now let's have let's discuss a few rules of indices. Should I move forward? Okay, is everything clear? That's great. Okay. Now there are a few rules of indices. The first and foremost rule that every student must know is that when we have same bases and different powers, this is further divided into two circumstances. What are those two circumstances? In one circumstance, we have a multiplication sign in between, and another case is a division sign in between. Now, what do we mean by that? Imagine we have two same bases. Let's say x and x, but we have different powers. So here it is x power 2, and here we have x power 3, and we have a multiplication sign in between. What's going to happen? The bases remain same, but the powers add up. Bases remain same, but the powers, they tend to add up. So what's going to be the final answer? It's going to be x raised to the power of 5. We have another example here with us. For example, here we have the division sign, and if I have y raised to the power of 5 and I have y raised to the power of 3, so I have same bases but different powers, and I have a division sign in between. Just like that, we have in the final answer we are going to have the base remaining same, but we are going to have powers subtracting. Powers are going to be subtracting, right? So this is basically the first rule or the first idea that we have to come up in the form of indices. Now, most students often get confused between the presence of a multiplication sign or a positive sign, and they tend to do what should not be expected from them. For example, you might end up having a question z raised to the power of 4 plus z raised to the power of 3. What students do is that they have the same base as z and they add up the powers. This is absolutely wrong. It does not work like that. And why it does not work like that, we are going to be studying this later on. Okay? But as of yet, this is all what you have to know. Just along with it, write down a very important exam note, and that is all properties of powers only work for multiplication or division, right? This is a basic rule that every student must be aware of. For example, if a student writes a raised to the power of, um, let's say 7 minus a raised to the power of 2, is that going to be a raised to the power of 5? Any answers? No, absolutely, you're right. So this is the first basic rule of indices. Okay? Once you're done, tell me. Okay, that's great. So let me erase all of that. So far clear? Yeah, that's fine. This is the first topic of O levels of or IGCSE. Oh no, you haven't missed anything, don't worry. If this is the first thing that you're doing so far, it's totally fine. Okay, now we have to study another rule. What is that rule? In the first example, we saw that we had the same bases but at different powers. Here we have different bases, different bases. This is the first condition, but same powers. Now, what do we mean by that? For example, if I'm writing x and y, I have. Okay, let me teach it the way I taught you in the first, as the first example. Here we multiply, and here we divide. If I have x and y, and between the two is a multiplication sign, and if I have x and y here, and between the two there is a division sign, but what I have this time around is that I have the same powers. For example, x squared multiplied by y squared, or y squared, sorry. Or if I have x raised to the power of 3 divided by y raised to the power of 2. In this case, we are having, in the final answer, we are going to be having x multiplied by y in a bracket, and 2 is going to be the power, the overall power, right? 2 is going to be the overall power. And just like that, this can also be written as, my apologies, I just wrote 3 here. It should be 2. It should be 3. I wrote 2 there by mistake because we had the same different bases and we need to have the same power. So this is going to be written as x divided by y over 3. So do you understand how those two rules are applied very differently? So this must never be confused with the first rule. If we have different bases but same powers, we will multiply those bases with each other and the power remains same. Unlike the first rule where we had the same bases but different powers, so the powers are going to add up or subtract depending on the multiplication or the division sign in between. Everything's clear so far? Okay. Yes, yes, we're going to be solving more examples of this. Don't worry. Okay, should I give you an example? Okay, let me give you an example right now. For example, a multiplied by b raised to the power of m. And if I tell you a plus b raised to the power of m, what's going to be the difference? Hmm? Yes, this is going to be a raised to the power of m. After that, multiplied by b raised to the power of m. Right? But in this case, we are going to be having an expansion, and that depends on the number of m's. We are going to be learning this rule later. This is what this is exactly what we call expansion. Expansion of algebraic identities. Move forward. That's great. Okay, okay. Sure, sure. No worries. The third rule that we need to know is, for example, we have a power over a power. For example, I have x raised to the power of 5 whole squared, right? So if someone says x raised to the power 5 squared, it's going to be different. Okay, first of all, I want all of you to tell me the difference between the two of them. What's the difference? What's the difference between this and this? Hmm? Yeah, go on. Yes, you're right, you're right. Absolutely. So if I say 5 squared, and let's say if I say minus 5 squared, and if I say minus 5 whole squared, the difference between them is that this squared is only on the value of 5, and this squared is entirely on. Yes, exactly. So the final answer of this is going to be minus 25, and the final answer of this is going to be 25, because this can also be written as minus 5 multiplied by minus 5, and as we know that when two minus signs are multiplied together, we have a positive answer, right? So just like that, we have a similar rule here. And what is that similar rule? That similar rule here is that x raised to the power of 5 whole squared, in this case we have x being copied down, and 5 will be multiplied by 2, which is going to be x raised to the power of 10. So it basically, we know one thing, that powers multiply with each other. Yes, powers multiply with each other. So let's say realistically, x raised to the power of 5 whole squared can also be written as x raised to the power of 5 multiplied by x raised to the power of 5, right? Right? So what was the first rule? Same basis, multiplication sign in between, powers add up. So are we getting that answer? We are, right? Are we? Yes. Let's say I am writing y raised to the power of 4 raised to the power of 3. Now, simply it can be written like this as well. But let's try to expand it. We have the same basis, powers are going to add up, right? Absolutely. Take it? Okay, that's great. Write it down, then we'll continue. Done writing? All of you? Okay, let's move forward. Okay, now we have another case, and that is of negative powers. Now, basically, if you have a calculator with you, and if you type on your calculator 5 raised to the power of minus 1, you will be getting an answer of 0 0.2 in the form of a decimal, or 1 upon 5. So the simple rule of negative powers is that in various circumstances, as I gave you the example of a centimeters, that 5 multiplied by 10 raised to the power of minus 3, we have a negative power, right? What do we mean by having negative powers? When we have a negative power, it can also be denoted as the rule is going to be simple. The methodology is going to be very simple. It's very simple. The simple methodology is that whenever we see a negative power, for example, 6 raised to the power of minus 1, this can be written as, first of all, first things first, you need to make a fraction. Then you need to have, you need to write 1 as the numerator. And then you will be writing each and everything once again, that is written here, but just remove the sign. So 1 raised to the power of 6 raised to the power of 1 is 1 upon 6, right? If I'm asking you, what's 4 raised to the power of minus 3? How can that be written? Make a make a fraction. These are the three rules. In case of negative powers, first write this down. In case of negative powers, make a fraction, write down 1 as a numerator, shift the values to the denominator, denominator, is the spelling right? I think it is. To the denominator, but remove negative sign. As simple as that. We'll make a fraction, we'll write down 1 as the numerator, we'll shift everything down, but here we're not going to be having 4 raised to the power of minus 3, we are going to be instead having 4 raised to the power of 3, which if we evaluated 4 multiplied by 4 multiplied by 4, it will be 1 over 64. Let's solve another example. 5 raised to the power of minus 2. It will be written as first making a fraction. 1 will be the numerator, and 5 squared will be the denominator. So 1 upon 25. Clear so far? Yeah, that's the reality. So basically, mathematicians they were not fond of the idea of having negative powers. Yeah, exactly. So they did not like the idea of having negative powers. This is what happened. Should I move forward? No, there are many rules to go. There are many, many, many rules to go. We're not done yet. And we still have a lot of time. It's just 20 minutes. Okay, but we are past the basic rules. Let's move forward. One very basic rule. Okay, I'll do that at the end. Now we need to have a look at fractional powers. What do we mean by that? Now it's not necessary that in all cases that you will be having let's say a numerator, oh sorry, a power in the form of a whole number. So there is always a possibility that you might have x. As of yet, the only thing that we had studied so far was x raised to the power of 1, or let's say 5 raised to the power of 2. But it's not necessarily a case. Guess you want to say something? No. It might work like that. Yes, 2 upon 2 can also be considered 2 upon 1, but we don't generally assume that. So just like that, that's a basic mathematical rule. What Yeah, basically what Abdullah is saying is that, for example, if I write x raised to the power of 2, in reality it can also be written as x raised to the power 2 upon 1. So yeah, he's mathematically right, but we don't assume that way. It can also be written as positive x raised to the power 2 upon 1, right? Or 5 upon 1, writing as a general. That's just occupying space and wasting your time. But I'm talking about real fractions right now, the proper fractions, right? For example, we have x raised to the power of 1 upon 2. So this is basically, this is also called surds. Not this, what we'll study now. X raised to the power of 2 can also be written as an under root of x. Now, I want all of you to go to your calculators and write 25 raised to the power 1 upon 2. And tell me, is it the same as under root 25? How can you get 12.5? No, no, no. Majay, it's not 25 multiplied by 1 upon 2. It's not that. Yes. What answer are we getting? 5? Yeah. So this is basically the first idea, that if we have 1 by half as the fraction, as a fraction in the as a power, we'll always be writing it as under root. For example, we have x raised to the power 1 by 3. This will always be written as cube root of x. Yes. Okay. So now I want you to have a look at two methods of solving these. For example, I write mm, 8 raised to the power of 2 by 3. Should I erase all of this? Wait a minute. Yeah. We have written this, right? For example, I just wrote it 8 raised to the power of 2 by 3. It can be done in two ways. Let's have a look at the easy way first. The easy way is that I can make a bracket, and in that bracket I can have 1 upon 3 here, and I can square it. So I squared the entire the basically the entire value of 8 raised to the power 1 by 3. Now, as of the third rule that we had studied, that was 2 multiplied by the inner like the fraction which is inside in the form of a power. This will always give us as, yes, yes, right? So this will also be considered equal, right? Now when I have 8 raised to the power 1 by 3, can I also write this as cube root of 8 whole squared? Can I? Or can I not? I can, right? What is this going to be? What's cube root of 8? It's 2. 2 squared is going to be 4. So this is method 1. Now what's the other method? The other method that we can employ is, the other strategy that we can use is, for example, we have 8 raised to the power 2 by 3, and if there is a student who is very who is fond of mental maths, he knows one thing for a fact, that 2 cube is actually 8. So instead of writing 8 in a bracket, we write this as 2 cube. Hmm? Right? So now what he does is that he multiplies the power within by the power which is out. So 2 raised to the power 3 multiplied by 2 by 3, powers of 3 cancel out, and this is going to be 2 raised to the power 2, which is 4. So are we getting the same answer? We are, right? We absolutely are. Great. Let's have a look at another example. Um, Wait, let me just diminish its size. Oh my god. So another example is 64 raised to the power of 2 by 3. If there is a student with an extraordinary mental maths, okay, let's do this first here. We're going to be making another bracket. 64 will be a part of that bracket, and we will be having 1 by 3, and we will square it. Now, that student knows one thing for a fact, that 64 raised to the power of 1 by 3 can also be written as cube root of 64. That will be whole squared. And cube root of 64 is? No, it's not 8. Yes, it's 4, absolutely. So 4 squared. What is that? It's 16, right? It is. And let's have a look here. 64 raised to the power of 2 by 3. If that student solves that method from the start, he or she knows that 64 can also be written as 8 squared, and the squared of 8 was going to be multiplied by 2 by 3. We will be having 8 raised to the power 2 multiplied by 2 upon 3. No, I did something wrong. It should not be. Oh, sorry. Yes, not only is it 8 squared, it should be 4 cubed. Yeah, my bad, sorry. This also happens during classes, right? So if we multiply the powers, 3 multiplied by 2 by 3, can 3 cancel? 3's are going to cancel off. We're going to be having 4 squared, which is 16. So are we having the right answer here? Just like we had the right answer here, right? Okay, copy this down. Done? That's great. Okay, let's discuss the next rule, and that is, I generally call it reverse powers. What do I mean by that? Now, this is not basically, this is not a mathematical rule, okay? I'm just calling it that in that way. If I have 5 raised to the power of 2 by 3 equals x, for example, whatever the value is, we don't know, right? In reality, I can also write this as 5 raised to the power of x raised to 5 equals to x raised to the power of 3 by 2. Now, what do we mean by that? This sounds confusing, right? Let's have a look. You see, when you people were in grade 8, we heard of something called reverse fractions or percentages. What did we mean by that? We studied that 25% of 8 equals to 8% of 25, isn't it? What's 25% of 8? What does that become? 2%, right? 25% is 2, right? And what's 8% of 25? Right? Oh, not 250, 25. It's 200 upon 100, which is 2, right? So this is like, this is not a part of the syllabus. Let me just write it down in not syllabus. This is a way of explaining this. So basically, whenever we have a base and on it we have a fractional power, and on the other side we have a constant whose value we don't know, we can also write this as 5 equals x raised to the power of inverse of that power. Not a negative inverse, inverse. I should have written that as inverse, by the way, not reverse, but okay. Inverse or reverse or inverse. For example, y raised to the power of 6 upon 4 equals 10. I can also write this as y equals 10 raised to the power 4 by 6. Done? Great. Let's study the last rule and then we can call it off for today. Okay, so the last rule that we need to remember is powers and decimals. Now, what do we mean by that? As you know that you might not always have a power in the form of a whole number, so you might not always have a base in the form of whole numbers, right? We might have bases in the form of decimals, 0.5 raised to the power of 2. But we know one thing for a fact, 0.5 can also be written as 1 upon 2, right? That's a simple rule to start with. So 1 upon 2 whole squared can also be written as 1 upon 2 multiplied by 1 upon 2. What does that become? 1 upon 4, 0.25. Am I right? But now let's twist it a bit. What if it's 0.5 raised to the power of minus 2? What is that going to be? It's going to be done in a very simple way. I'll explain it. 1 upon 2 raised to the power of minus 2. Look at it again. Can I also write this as a reverse of that fraction, which means 1 upon 2 raised to the power of minus 2 can also be written as 2 upon 1 raised to the power of 2. It can be, right? Can it? Absolutely, yes. So 2 upon 1 is 2, which is 2 raised to the power of 2, which is 4. Let me solve another one. 0.2 raised to the power of minus 2. What does that become? 0.2 can also be written as 1 upon 5, right? This can be written as 1 upon 5, 1 upon 5 raised to the power of minus 2. Am I right? But if we find a reciprocal of it, the reciprocal of 1 upon 5 is 5 upon 1. We are going to be changing the sign of the index. 5 upon 1 whole squared is 25 upon 1, which is 25. Simple as that. Great. Write two more rules. X raised to the power of 0 equals 1, and x or y raised to the power 1 always equal x or y. These are the two basic rules that we need to know. So I do not need to give any evidence for it, which is like, for example, x raised to the power 0 equals 1. Anything which is raised to the power of 0 will always be 1 under any circumstance. Okay? Done? That's great. Any questions? If there are, you can stay, otherwise you're free to leave. Yeah, tomorrow we're going to be no, let's in fact let's see what I'll do in the next session. We might solve some few equations. Okay, right? Otherwise, you're free to leave. Goodbye.